Good morning, everyone. Today we are going to discuss about municipal water treatment. Is it clear for all? So, what is municipal water treatment? Before that, we must know the word of potable water. Municipal water treatment. What do you know about potable water? Any idea? Potable water. Say the answer. Potable water means yeah, drinking water. Okay, drinking water. So that water, how it has to be. Okay, we are going to see first specification of drinking water. Potable water means drinking water. We are going to see the specifications. Okay, specification of what? Say the answer. Specification of drinking water. Okay, how the drinking water has to be. Okay, you can take your phone. I'll give one QR code. You say the answer. Is it clear for all? Yes, you proceed, ma. Yes, in the screen QR code is there. You scan the QR code and you know what you know about, that is how the drinking water has to be. You type. Have you all scanned? You scan. You scan the QR code. Is it working? You check. QR code is working. Say anyone reply. Answer. QR code is working. Yes. Have you all scanned? Anyone need this still not yet scanned? Then you type that. There you can give three answers. How the drinking water has to be. We will see the answer afterwards. See, press the water, that presentations. What are the specification of drinking water? Yes, that one. Specification of drinking water. Yes. Odorless, colorless. Who is writing God? That is good, I think so, isn't it? G-O-O-D, good. Why you have written cat, God, and all? Use it properly. How the drinking water has to be. Yes, cat and dog is there, means we cannot drink. Odorless, colorless. See, colorless, so many people are giving. That is why the font size is increased. Have you all understand? Yes, you can apply one more time also, not only one time. You can submit many more times. Yes, it should be pure. Yes, so many people are giving. Next, submit பண்ணுங்க, submit it fast. Submit. If you want QR code, I will show the QR code also once again. Anyone not yet scan that QR code? Scan, you can submit it one more also. Yes. Tasteless, good. Colorless, pure. Odorless. H2O alone is given. Odor free. Yes. Free from pathogens. Very good. Less turbidity. Very good. And pH must be 7. Very good. And what is given? Then free from pathogens, free from minerals. Very good. Very good. So many answers I received. Okay, very good. Thank you very much for your response. Okay, now you close your phone and all. Thank you. Thank you very much. We will see the specification one by one. Go to fifth slide, slideshow. Okay, so what you have said is, odorless, colorless, everything is correct. Next. So what is the first point I have written is odorless, colorless and less turbidity of 25 ppm. Turbidity means you all know that, isn't it? The dirty water or some particles are there, means that is called as turbid water. Next. So it should be free from pathogens and it should be free from harmful dissolved gases. So gases may also be present inside the water. Okay, what type of gases? Example for that gases, what is given, ma? H2 interactive section, so you answer H2S and ammonia. Okay, then it should be free from minerals like lead, chromium, arsenic. Such minerals should not be present. Next, pH should be 7 to 8.5. That is, pH should be neutral. Okay, yes. Next, That is, hardness should be less than 150 ppm. Hardness means you know, isn't it? What is hardness causing ions? Say some example of hardness causing ions. Ca2 plus ions as well as Mg2 plus ions. Next one is total TDS, that is dissolved salts. Okay, that has to be less than 500 ppm. This is a 2-mark question. Among this, you have to write at least 5 points. That is free from pathogens, free from minerals, pH should be 7 to 8.5, odorless, colorless. Okay, so then the hardness should be less than 150 ppm. Likewise, it has to be there. Is it clear for all? That this is 2-mark question is over. Now, we are going to see various stages. Okay, municipal water treatment. First, we have discussed the specifications. Next one is we have to see introduction. Okay, what is the introduction? What you can write? That is, you can write the sources of water. Next, sources of water means say some source, how we are getting the drinking water. What are the rainwater, river water? Very good. Next, lake, pond. Okay, so these are the various sources we are getting. Okay, then afterwards, how we can purify it? That has to be purified. For if we are using for drinking purpose means it should be clean. Okay, so we have to purify it. What are the various stages or that? That one we are going to discuss. Okay, then the next point is various stages. This is a part B question, 16-mark question. Okay, sometimes they can ask specification of water as a 2-mark question. Okay, so first side heading you can write it as introduction. Okay, next side heading we are going to see what are the various stages are there in the municipal water treatment. We are having two treatment. First one is primary treatment. What is the first one, ma? First one is primary treatment. Second one is secondary treatment. Listen the class. In between, you are having one more recap questions also. Okay. During that time, I will ask. You must say. Okay. So listen the class carefully. Easy questions only you can answer. Then primary treatment and secondary treatment we are having. And under primary treatment, see the PPT we are having. What are the primary treatment are given? First one is screening. What we are having? Screening. Second one is aeration. Second one is aeration. And the third one is sedimentation. Third one is sedimentation. And the fourth one is coagulation. Fourth one is coagulation. And the fifth one is filtration. What are the various stages? Any one of you say yourself, you say. Filtration. Okay, so we will see one by one by seeing the PPT itself. Okay, we will see one by one by seeing the PPT itself. So here various stages are given. See the PPT, screening, aeration, sedimentation, coagulation, filtration. This is a primary treatment, and the secondary treatment is sterilization or disinfection is called as secondary treatment. Okay, next we will see one by one. Screening. See here, I am giving the content as well as the image also. Okay, so screening, first what we are done. Okay, then during that time, what happened? Yeah, first point is screening shutters with variable size receive holes. That is shutter we are using. Have you all understand? Shutter with various size holes will be present. How it will be means it will be act like our filter. What we are using in our home and all, you know, we are using filter, isn't it? Such a way it is used. So here, see, this is the shutter screens are given. So during that time, what happens? What happens? It removes the floating materials, especially leaves, plastics, or any paper or wood, anything is there means it removes. Have you all understand? So what we are doing? We are keeping shutters. During that time, which is removed? Which is removed? Floating materials are removed. Okay, so this is the function of screening. Then next, aeration. See the picture. Such a huge water area we are covering. Okay. So in that water we are passing air. Aeration means we have to pass air. If we are passing air during that time, what will happen? That is, it oxidizes. It increases the oxygen content. If you are increasing air, that is, if you are passing air, what will happen? Oxygen content is increased. What is its use? It removes harmful gases like carbon dioxide, H2S, NH3. What is H2S? H2S means, say louder, hydrogen sulfide. Okay, NH3 means ammonia. Okay, NH3 means ammonia. These harmful gases which is dissolved in water will come out if you are adding air. Okay, that is the first function. Then during that time, second one is what is given? It oxidizes iron and manganese salts by converting it into their hydroxides. Okay, that is we are convert ferrous. For example, ferrous sulfate is present means ferrous means Fe2 plus. Ferrous means Fe2 plus. It is oxidized to Fe3 plus. Okay, manganese salt Mn2 plus. It may be converted into Mn4 plus salts. Okay, so this is takes place during the aeration. First portion, first stage is screening is over. We are removing the floating material. Second one is what we are adding? Aeration. We are passing air. We are removing the harmful gases as well as we are oxidizing the salts. Okay, inorganic salts. Yes, next. Sedimentation. See, these are all the sedimentation tank. Could you able to see? These are all sedimentation tank. What we have to do? We are we should not disturb the water. We are giving the water. We are allowing the water to settle. That is, any suspended particles or anything is present. So, okay. So such a things will be settled down at 2 to 8 hours. Okay. Then it removes 75% of suspended or coarse impurities like clay and sand by settling at bottom. So if you are giving time, automatically because of its gravitational force as well as if you are automatically it's settled, any turbidity is there, automatically it's settled. That is called as sedimentation. That is the picture of sedimentation tank. Could you understand? Shall we go to the next one? Coagulation means we are adding alum. Okay, what we are doing, ma? We are adding alum. Alum means aluminum sulfate. See the equation, Al2SO4 thrice. Okay, so aluminum sulfate is converted into aluminum hydroxide. Okay, aluminum hydroxide, it is a gelatinous gel-like precipitate. What it will do means, it will entrap any fine particles are there. That is abstracted by this coagulation process. So during that time, all the 100% suspended particles, any fine particles are there, then that is also settled down. We will see the picture, you can understand easily. So this is how we are, after adding the alum, this is how we are seeing the water. Okay, next slide. See here, this is the water we have, which has impurities, that is small particles are there. Have you all understand? Next one is we are adding coagulant. If we are adding coagulant, see the size of the particle, it will be increased. Okay, that is this. It will attract. That is the precipitate, gelatinous white precipitate. What is the gelatinous white precipitate? Al, OH thrice. Okay, that one attracts this one and automatically in the last step it settles down. Okay, that is the coagulation step. So fourth step is over. Then the next one is filtration. Okay, sand filter is used. Sand bed filter. So here we are having four stages are there. That is, otherwise we can say, see here, this is how we can write. So here you are having small sand bed. Okay, fine sand we can say. So fine sand, there are four layers are there. What is the first one is fine sand layers. This is around 1 meter. Okay, then afterwards I am having, this is coarse sand. Okay, then afterwards what I am having? I am having gravels, small gravels. Okay, so we can say small gravels. What is meant by gravels, ma? Bubbles. Okay, small stones. Okay, at the bottom we are having coarse. Coarse means bigger one. This one is coarse gravels. So this is around 1 meter thickness we are having. This coarse sand has to be 0.3 meter. At the top we are passing the raw water. Okay, so here what we are doing, filtration takes place. Then afterwards this is the outlet. Pure water we can collect it. Filtered water we can collect it. We cannot say pure water. We can say this is filtered water. So this is the sand bed. Have you all understand? This is filtration is over. The next one, now this is the time for you to check. Up to this we have completed primary treatment. Okay. So I will give one questions I will give. What you are going to do means I will ask anyone. Okay. During that time you have to answer. Okay. Are you ready now? Shall I start? Okay. First question. This is the first question. Okay. Few minutes time. Okay. Anyone? Anyone answer? Anyone? Stand up. We will take the answer afterwards. Stand up and say. What is the question? The main purpose of screening in water treatment is remove floating materials like leaves and plastic. Are you all agree with this answer? Yes, correct. Then next question. We will check the answer. Yes, fine. It's correct. Okay. Then next, during the aeration process, water is anyone? Anyone stand up and answer. Yes, mixed with air to increase oxygen content. Very good. Shall we check the answer? Yes. Check. Yes. Good. Yes. The next question. Anyone? Question is aeration helps in the removal of. Anyone stand up and say. Dissolved gases such as CO2, H2S, NH3. Shall we check the answer? Yes. Correct. Good. Yes. Next question. Sedimentation primarily removes. What it removes? Anyone? Those who know? Yes, pores and suspended particles like sand and clay it are removed. He say, okay, we will check the answer. Correct. Very good. Good. Sit down. Next, what is the in which stage? Anyone? Stand up. Stand up and say. Stand up and say. Yourself to say. Coagulation. Very good. We will check the answer. Correct. We will encourage. Yes. Next. Read the question and say the answer. If you know, stand up and say. Yes, yourself. ALOH thrice. In the coagulation process, alum reacts with water to form aluminium hydroxide. Good. Shall we say that? Check the answer. Correct. Next. The purpose of filtration. Anyone? 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 Be quick. Try. Filtration. Shall we see the answer? Next one is secondary treatment. Okay, that is sterilization or disinfection. Sterilization means here we are doing that by 4 ways. Okay, the first one is boiling, ozone and chlorine, UV light. There are 4 ways we are using. Okay, then during that time, well, you already said, isn't it, during the specification of drinking water, how the water has to be free from pathogens. Okay, that is pathogens means microorganism, harmful microorganisms. Example for microorganisms, bacteria, fungal, virus, everything. Okay, that has to be removed. Okay, for that purpose, we are doing sterilization. There are 4 methods we are using. First one is boiling, second one is ozone, next one is chlorine, next is UV light. Next. So, out of this sterilization, next we are going to discuss filtration. We have finished. Okay, so next we have completed this one. So this is the filtration sand bed. Okay. Then next, yes. So boiling one by one we will see. So 10 to 15 minutes. If you boiled, what about the water nature? Nature of the water during fever and all. Our parents will insisted us to drink a sufficient amount of hot water, but we don't want to drink. What's the reason? What's the reason that water? But during summer time, if you are having a refrigerator, means we will go to the ice water, isn't it? So why we are not interested in drinking the hot water? During that, what will happen if the water is boiled more? The taste, yes, the taste is changed. Okay, so moreover, we cannot boil a higher volume of water. Next one is using ozone. Ozone, you all know that, isn't it? O3. That is O3 decomposed to give oxygen and a nascent oxygen. It is highly unstable. Okay, that is why we are using. But if you are using excess also, it is not harmful. But at the same time, it is costly. Okay, so we cannot use it for a long period of time. Okay, next one. So see that this is ozone. So it absorbs water, germs, anything means it absorbs everything, that nascent oxygen, the blue color oxygen. Then afterwards we are getting oxygen alone. Have you all understand this picture? Yes. The next UV, that is in the swimming pool we are using. How we can prepare this UV radiation means when we pass electric current to the mercury vapor lamp. Okay, during that time we can get it, but this is also costly. But one more disadvantage is turbid water cannot be treated. Okay, next, by chlorination. This is important method. Most we can use it often also. Okay. So under that, how we can pass chlorine means in 3 or 4 days. There are various ways we can use it. Okay. First one is we are passing chlorine gas as it is to the water. Okay. Second, to kill bacteria. Second one is we are adding. First, what's the first one we are doing, ma? Adding chlorine gas. Second one, we are adding chlorine and ammonia, and it will form the chloramine. Okay, see the equation, Cl2 plus NH3, and it gives chloramine, Cl NH2 plus HCl. Okay, so it does not produce any irritating odor. Moreover, it increases the taste. If you add ammonia, chloramine formation is there, means it increases the taste of the water also. Yes, next. So next, third one is bleaching powder. What is bleaching powder? Formula is given. Say CaOCl2. Okay, that CaOCl2 dissolved in water and it gives chlorine. That chlorine again dissolved in water. What it forms? Chlorine dissolved in water. What it forms? See the PPT content and say HCl plus HOCl. What is HOCl? Name? Hypochlorous acid. Okay, hypochlorous acid is also formed. Okay, so but we have, while we are adding this chlorine, we have to add a little bit higher than that of the breakpoint chlorination. So the last 5 minutes, only one graph I will explain. With that, I will conclude. So what is a breakpoint chlorination means? That is, we are adding that chlorine, that chlorine has to destroy bacteria, ammonia, and organic impurities and inorganic impurities. Totally how it has to destroy? 4 things. One is it removes bacteria. Second one is it removes ammonia. Third one is it removes organic impurities. Fourth one is it removes inorganic impurities. Next. See the thing. First one is we are adding here. See that chlorine dosage. This is what we are applying. See here. If you are taking, this is the residual chlorine. In the y-axis, what we are taking? Residual chlorine. Here, chlorine dose means what we are applying. How the graph you will draw? 0, 10, 20, 30, likewise. Am I correct? Here, what we will write? 0, 10, 20, 30, likewise, we are adding. Okay. What is meant by residential area means what? Residential area means living area, isn't it? That is residual chlorine means we are adding chlorine. How much amount of chlorine is kept inside the water we are going to find out. Okay. So first initially, see the graph. Initially we are adding chlorine 0 to 1, but there is no residual chlorine. All the chlorine are used up. That is why what is the function of this chlorine? that chlorine is used to kill the bacteria. Have you all understand that chlorine is used to kill the bacteria as well as it oxidizes organic impurities and all. Okay. Afterwards, that is that at point A only, what will happen? Chloramine compounds are started to form. That is why it increases. See the curve AB. The AB curve is increases. So the PB is the residual chlorine is high at the point of B. Okay. Then afterwards, what will happen? Still we are adding means what will happen to the graph C? Point C, see the point C. So during that time, what will happen? The chlorine is used up. That chloramine formed and that chloramine destroy and it gives chlorine gas, and that chlorine gas is used to kill the remaining bacteria or organic impurities, anything is there. It completely removes everything. So that point B is called as breakpoint chlorination. Afterwards, if you are adding means it is exists as a free chlorine only. Okay, so this is one of this breakpoint chlorination. Based on this graph only, we find out how much amount of chlorine has to be added to the particular amount of water. For example, 1 kg of chlorine has to be taken means it should be dissolved in 1000 liters of water. Okay, with this I will stop. Next, we will see this one. This is the explanation is given. Next, so these are the advantages of breakpoint chlorination. Advantages, see, advantages is remove bacteria and ammonia and it prevents the growth of algae in water. Okay, next summary we will see. Method of sterilization, boiling, ozonization, next UV treatment, chlorination, next breakpoint chlorination, advantages. Okay. So today up to this we have to write. This is municipal water treatment. Thank you very much.